Hello and welcome to the Quick Solutions All India AIATS Test Series JEE Advanced 2020 Test 5A Paper 2 Code C and D Physics. Let's go to question number 1. Question 1 says the cart of mass 2m is initially at rest on a smooth horizontal surface. A particle of mass m is attached to the end of a light rod of length L pivoted freely at the ceiling of the cart. Rod is released from its horizontal position as shown. At the instant when the rod becomes vertical, option A says displacement of particle in horizontal direction is this much. Option B says displacement of particle in horizontal direction is this much. Option C says tension in the rod is 4 mg and option D says tension in the rod is 3 mg. So essentially we have to work out displacement of particle in horizontal direction and tension in the rod when the rod becomes vertical. Well, in terms of concepts, the question involves the principle of conservation of linear momentum and which means it involves displacement of center of mass and of course the laws of motion, because the tension will come by applying the concepts of laws of motion. So let's get going. Now we can see that on the system of the particle and the cart there is no external horizontal force, and which means that the acceleration of center of mass horizontally is 0, and since the center of mass was initially at rest, in fact the displacement of center of mass of the particle and the cart system horizontally is going to be 0. Well, with that in mind, now we assume that the displacement of the particle horizontally is x1 and the displacement of the cart is x2. Then what we have is mx1 plus 2m times x2 will be 0 because the horizontal displacement of center of mass is 0. Now this simplifies to x1 plus 2x2 is 0, that's 1. And secondly, when the rod becomes vertical, then the horizontal displacement of the particle with respect to the cart has become L, which means that x1 minus x2 is equal to L. Now let's solve these two equations. Basically we are concerned with the value of x1. So let's multiply the second equation by 2. We get 2x1 minus 2x2 equals 2L, and this is one equation, this is 2 and this is 3. So we add 1 and 3 to get 3x1 is equal to 2L, or that means x1 is simply 2L by 3. So that means the horizontal displacement of the particle is 2L by 3. So option B is correct and option A is incorrect. Let's find the tension in the rod now when the rod has become vertical. Now to solve this, we'll also apply the concept of conservation of mechanical energy and of course the laws of motion. Now we can see that when the rod becomes vertical, there is loss in gravitational potential energy of the system, which converts to the kinetic energy of the particle and the cart system. The mechanical energy will be conserved because the only forces doing work here are conservative forces. Now that being the case, we have mgl is the loss in potential energy is equal to half m v1 square plus half 2m v2 square. Now at this instant the velocity of the particle and is also horizontal, and of course the velocity of cart is always horizontal. Now we also need to conserve linear momentum because linear horizontal momentum of the system is always 0, which means that if the particle has velocity v1 towards right, the cart has velocity v1 by 2 towards left because its mass is twice that of the particle. So conserving mechanical energy, the complete equation will be then mgl is equal to half mv1 square plus half 2m, and the speed of the cart, as I said, is v1 by 2 square. Let's solve it. Let's simplify it further. So we have 1 by 2 plus 1 by 4, that means 3 by 4 mv1 square, and this gives us the value of v1 square itself is 4 by 3 gl. That's the value of v1 square. The v1 itself is going to be 2 root gl by 3 And well, at that particular instant, the cart is not accelerated, right? Because there's no horizontal force on the cart at that very moment, and vertically it's not going to accelerate. So the cart itself will be an inertial frame. Now, so we can consider that the particle is in circular motion with respect to this point, and which is an inertial frame. So if we consider that, then the value of t minus mg, because if we look at free body diagram of the particle at that instant, so there is, say this is the particle, this is mg, and this is t, and it has some acceleration upward, and that acceleration is m, v relative at this point, right, by L. Now what is v relative? V relative will be v1 plus v1 by 2, because as I said, the cart has velocity half that of the particle at that very moment, but in the opposite direction. So let's apply that then, m by L, and v relative square, as I said, is 3 by 2 v1 square, and that means it is 9 by 4 into 4 gl by 3. Let's simplify it further now. So this basically is 3 mg, and which gives us that t is equal to 4 mg. If you look at the options, it is matching with option C. C is correct, and then that means D is incorrect. So for question 1, options B and C are correct. Let's now move on to the next question. Question 2 says a particle is projected from a point on the ground with velocity 20 meter per second at an angle of 60 degree with horizontal at time t equal to 0. At a certain point on its trajectory, particle is moving at right angle to its initial velocity of motion with speed v0 at time t0. G is given to be 10 meter per second square. Then there are options about values of v0 and t0 and radius of curvature of trajectory at t0. Okay, obviously the question involves concepts of projectile motion and also circular motion, where we find radius of trajectory of particle. Let's say this is the trajectory of the projectile, and this is the velocity of projection, which is given as 20 meter per second. This angle of projection with horizontal is given as 60 degree. And at some point, the velocity has become perpendicular to this velocity. Let's say at this point, and this angle, that means is 90 degree. This is velocity v. Let's draw a horizontal line through this point. We can see that this angle is 60 degree and this angle is also 60 degree. This angle will be then 30 degree. This angle is 30 degree. Now we can find v easily by equating the horizontal component of velocity of the projectile, which we know is not going to change during its motion. That being the case, we have v cos 30 degree. V cos 30 degree is equal to 20 cos 60 degree, which is 10 meter per second. And that means the value of V is 10 by cos 30, which is root 3 by 2, or 20 by root 3 meter per second. And that value has been called V0. So V0 is 20 by root 3 meter per second is the correct option. Option A is correct and option B is incorrect. Let's now work out the value of T0. So to find the value of T0, we look at the vertical component of velocity of the projectile. We call it Vy. We are calling the upward direction as the y direction. So Uy is 20 sine 60 degree. That means 10 root 3 meter per second. Whereas Vy, when the speed has become 20 by root 3 meter per second, at that instant Vy will be negative, because its vertical component, we can see that is in downward direction, and that is equal to 20 by root 3, in fact minus 20 by root 3 sine 30 degree. So this is minus 10 by root 3 meter per second. Now we can apply V is equal to U plus 80 in the vertical direction, and that will give us minus 10 by root 3 is equal to 10 root 3 minus 10 t naught, because Ay is minus G or minus 10 meter per second square. Solving, we get T naught is equal to root 3 plus 1 by root 3 second, which is 4 by root 3 second. So that means option C is also correct. Let's now evaluate the radius of curvature at that instant. To find the radius of curvature, we require V, which we already have, that is 20 by root 3 meter per second. And if at that instant, let's draw this trajectory again. Say here is velocity V and acceleration of the particle is G vertical downward direction. But in the plane of motion, we take component of G perpendicular to velocity, and we found that this angle is 30 degree. This angle will also be 30 degree. So that means AN, the component of acceleration perpendicular to velocity, is G cos 30 degree or 10 root 3 by 2 meter per second square, or simply 5 root 3 meter per second square. So the radius of trajectory is V naught square by AN, and that means its value is 20 by root 3 square, which is 400 by 3 into AN, which is 5 root 3. Now this value is 80 divided by 3 root 3 meter. Well, option D says radius of curvature of trajectory at time t naught is 40 by 3 root 3. So it is not matching with this. So option D is incorrect. So for question 2, the correct options are A and C. Let's move on to the next question now. Question 3 says a right angled triangular frame PQR made by light rods is freely pivoted at point P. System shown in the figure is in equilibrium. If pulley and strings are light, then given G is 10 meter per second square. Tension in string 1 is this much. Tension in string 1 is this much. Hinge reaction by the pivot on the frame is this much. And option D says hinge reaction by the pivot on the frame is this much. Okay, so we have to find tension in string 1 and also the hinge reaction at that instant on the frame by the pivot. Well, the system is in equilibrium. The frame itself is in equilibrium, and so this pulley and the blocks will form an Atwood machine, and we can find tension in the string connecting the blocks as well as in string 2. So in string 2, we know tension in string 2, we can straightaway write it is 2 times tension of the string connecting the blocks. So the value of tension in string 2 is 4 M1 M2G. We can apply the formula straight away by M1 plus M2. Let's see, this value is how much? This is 4. M1, M2 is 5 into 5. That's 25 into 10 divided by 10. So this is 100 Newton. Now we have to find tension in string 1. Now to find tension in string 1, we look at the rotational equilibrium of the frame. And on the frame, if we see the external forces, we can see that this is tension 2, whose value is 100 Newton. We just found. Well, on this frame, external forces are T2 in this direction. The value of T2 is 100 Newton. We just found. And there is T1 in the vertically downward direction. And of course, there will be the hinge reaction too. But we are first finding the value of T1. So there is some hinge reaction. We can see that the hinge reaction will have components in the vertical upward direction to balance the vertical components of T1 and T2. So we can call it, let's say, Fy. And there will be a horizontal component to balance the horizontal component of T2. And that is something like this. Okay. So this is X, let's say. Now let's talk about point P. And we know that the net torque will be 0 to ensure rotational equilibrium. So torque about point P is 0 gives us the result that T2 into 1 meter, that means 100 Newton meter, that's the torque in the clockwise sense, is equal to tension in string 1 into the moment arm, and that moment arm will be 1 cos 45 degree because this angle is 90 degree and these two angles are 45 degree. So T1 into 1 cos 45 degree, that means into 1 by root 2. Now this gives us the value of T1, tension in string 1, and that is 100 root 2 Newton. So if you look at the options, option A is incorrect and option B is correct. Let's now find the hinge reaction. Okay. Now we can see that Fy is value of Fy we can give is equal to T1 plus T2 cos 45 degree. It is T1 plus T2 cos 45 degree. Let's put the values. It is 100 root 2 T1 and plus 100 by root 2. That's the value of Fy. Again, which simplifies to 150 root 2. So Fy comes out to be equal to 150 root 2 Newton. You can see that by simplifying this value. And Fx will be in the negative x direction. So Fx is actually equal to minus of T2, again cos 45 degree. So T2 by root 2. And this value is T2, we already have 100 Newton. So it's minus 100 by root 2 or 50 root 2 Newton. So the hinge reaction will be then minus 50 root 2 I cap plus 150 root 2 j cap Newton, which is matching with option C. So for question 3, options B and C are correct. Let's go on to the next question now. Question 4 says, pulleys and strings shown in the system are light. At the instant shown, if string on the right is pulled with constant velocity of 12 meters per second, then the options are about velocity of 5 kg block and acceleration of 5 kg block. So the question is essentially based on the concept of constraints. So let's use the constraints to find answer to the question. Now we can see, let's call this as y, this dimension as y, this is a constant, and let's call this as L. Now what is given? So this is L by symmetry, this is also L, and what is given to us, let's get it straight, because the string is pulled with velocity 12 meters per second. So in fact 2 times minus dl by dt has been given to us and its value is 12 meters per second. Okay, so this is given. Now let's apply the Pythagoras theorem here, and we have y square plus 5 square is equal to L square by applying Pythagoras theorem in this right angle triangle. Now we differentiate this with respect to t, so that gives us 2y dy by dt is equal to 2L dl by dt, and which means that minus dy by dt, which will be the velocity in the upward direction of the 5 kg block, is equal to L by y into minus dl by dt, dl by dt. Now at the instant shown, the value of L, again, because this is 12 meter, y is 12 meter, so this L will be 13 meter by applying Pythagoras theorem, and so this value is 13 divided by y is 12, and minus dl by dt we saw will be 6 meter per second, so into 6, this is coming out to be 6.5 meter per second. So that means option A is correct and option B is incorrect. Now we need to get acceleration of the block, so we can differentiate this equation once again to find the expression for acceleration of the block, and to do that we can strike off 2 on both sides, and then we apply the product rule. So dy by dt into dy by dt, that means dy by dt whole square plus y into d2y by dt square, this term is going to give us the acceleration, is equal to again dl by dt whole square plus L into d2L by dt square, which is going to be equal to 0 because the string is pulled with constant velocity. That term is simply 0. Now let's put the values. We have y into d2y by dt square is then equal to dl by dt whole square, and the dl by dt we saw is equal to minus 6. So this is 36 minus dy by dt whole square will be 13 by 2 whole square. Let's simplify it further. So this is 144 minus 169 by 4, and so the value of d2y by dt square is equal to minus 25 by 4, and then we have to put the value of y, which is 12 at that instant. So this is coming out to be minus 25 by 48 meter per second square. So The magnitude of acceleration is obviously 25 by 48 meter per second square, and which means option C is clearly correct. Option D is incorrect. So that means for question 4, options A and C are correct. Let's go on to the next question now. Question 5 says a water drop of radius r falls in air with uniform velocity. Density of water drop is rho and surface tension is T. The radius of curvature of drop at topmost point is R1 and at the bottommost point is R2. A and B are points just inside the drop. Then options are about PB minus PA and mod of R2 minus R1. Well, the drop is going down with uniform velocity. So that means for pressure variation, the G effective is simply G because the acceleration is 0, and which means we can say PB minus PA. We can apply the formula rho G effective into H. H is equal to 2R. G effective is G. So it's rho G into 2R. So we can put 2 in the front, and this is expression for PB minus PA. So option A is clearly correct. Let's get the expression for R2 minus R1. Now we know that PA is equal to P naught plus, it's a water drop, so 2T by radius of curvature at the topmost point, and that is R1. Similarly, pressure at point B will be P naught. The pressure outside I am considering is P naught. So pressure at B is P naught plus 2T by R2. Now we can see that PB minus PA is equal to 2T into 1 by R2 minus 1 by R1. Let's simplify it further. This is equal to 2T into R1 minus R2 by R1 R2, and PB minus PA value we saw is 2 times rho G R. So this gives us that R1 minus R2 is equal to 2 rho G capital R into R1 R2 divided by 2T. Now R1 and R2 we can consider they are still very close to R. In fact, R1 R2 can be replaced by capital R square. So R1 R2 we can replace by capital R square. So if that is the case, then the value of R1 minus R2 is actually equal to rho G R Q by T, which is actually matching with option B. So option B is correct. Let's go to the next question now. Question 6 says a ball of mass 10 kg is attached to the lower end of a light vertical spring of force constant 1000 Newton per meter. The upper end of spring is fixed. The ball is released from rest with spring at its natural length and comes to rest after descending through distance x. Then choose the correct options. Option A says x is 10 centimeter. Option B says x is 20 centimeter. And option C says magnitude of acceleration of the ball is z by 2 at 2 points during the motion separated by a distance of 10 centimeter, and option D says time taken by the ball to reach mean position for the first time is pi by 20 seconds. Well, obviously the question involves the concepts of work, energy and power as well as oscillations. It's a spring ball system. So to find the value of x, we apply the concept of work energy theorem. So let's apply the work energy theorem. So applying the work energy theorem, in short I am writing WET, work energy theorem gives us work done by gravitational force plus work done by spring force at maximum elongation when the ball has come to rest. This is equal to change in kinetic energy. So final kinetic energy is also 0, initial is also 0, so the change is also 0. This gives us mg x minus half k x square is 0, and this simply gives us the value of x as 2 mg by k. Now if we put the values, the value of x comes out to be equal to 2, and then m is 10, so it's 100, 200 divided by 1000, and that is 0.2 meter. And in centimeter it is 20 centimeter. So that means option A is incorrect and option B is clearly correct. Now to evaluate options C and D, let's consider what's happening here. Say this is the arrangement. So this was the initial position of the ball. So from this point it has descended through to this point. This value is x. equal to 20 centimeter. So in fact the net force is 0 somewhere here, exactly midway between the two. You can easily check that, and this value is 10 centimeter. So what will happen is that the ball will perform SHM, vertical SHM with amplitude of 10 centimeter. And option C and D say magnitude of acceleration. Option C says magnitude of acceleration of the ball is g by 2 at 2 points during the motion separated by a distance of 10 centimeter. Well, so what it's saying is that we have to consider, we know that since it is performing SHM at equal distance from the mean positions, the magnitude of acceleration is equal. Now, supposing this is, if this distance is 10 centimeter, then each of this half is 5 centimeter. Let's simply find acceleration at 5 centimeter distance, and we know that acceleration in this case is, rather mod of acceleration can be given as mod of omega square. X is displacement from the mean position. The value of omega square is k by m. The value of k is 1000, m is 10, so it is 1000 by 10, that is 100. And the value of x is 0.05 meter. This is coming out to be 5 meter per second square, which is actually g by 2. So accelerations at these 2 points will have magnitude g by 2 for sure, and which means option C is correct. Now option D says time taken by the ball to reach mean position for the first time is, well, if it is reaching mean position for the first time, the time taken, it is 1/4 of the cycle, 1/4 period. So the time will be t by 4, where t is 2 pi root m by k. And let's evaluate this. This is 2 pi, m is 10 and k is 1000. So this value is again 2 pi by 10, or simply pi by 5 seconds. So t by 4 will be pi by 20 seconds, and that means option D is correct. Let's go to the next question now. Question 7 says two conductors A and B, each of cross-sectional area A0, are connected in series as shown in figure. Ends P and R of rods are maintained at temperature of 100 degrees C and 0 degrees C respectively. At steady state, temperature of junction Q is 75 degrees C. Then option A says K1 is equal to 3K2 if L1 is equal to L2. Option B says K2 is equal to 3K1 if L1 equals 2L2. Option C says K1 equals K2 if L1 equals 3L2. And option D says K1 equals K2 if 3L1 equals L2. Well, clearly the question is from the topic heat transfer by conduction, and it's a steady state conduction. We have been given that temperature at this junction P is 100 degrees C, and at R it is 0 degrees C, and at Q is 75 degrees C. So if the rate of heat flow is H, then we can say that H is equal to K1 A0, the area of cross section, and the difference in temperature is 100 minus 75, that means 25 degrees C, divided by L1 is equal to K2 A0. The temperature difference at the two ends on the right rod will be 75 degrees C, divided by L2. So this simplifies to K1 by L1 is 3 times K2 by L2. Let's evaluate the options one by one. Option A says K1 is 3K2 if L1 is equal to L2. If L1 is equal to L2, we can see that K1 will be equal to 3K2. It's clearly being seen here. So option A is correct, and which clearly means that option B will be incorrect. Let's evaluate option C and D now. So what happens if L1 is 3L2? If L1 is 3L2, then K1 will be 9K2. So option C is incorrect. And if 3L1 is equal to L2, so if we put L2 equal to 3L1, we can see that K1 and K2 are equal. So that means option D is also correct. The other two options, that means option B and C, are incorrect. A and D are correct. Let's go on to the next question now. Question 8 says a small hole is made in a thin-walled hollow sphere of mass m and radius r. Consider a point P just below the hole. Let EP vector and VP be the gravitational field and gravitational potential at point P. Then two of the options are about VP and the the other two options are about magnitude of EP. Well, let's start with EP. So what we do here is we apply the principle of superposition for gravitational field. So we know that the gravitational field inside this thin walled sphere, when it's complete, will be 0. When the hole is not met, is 0. So that means gravitational field EP due to the remaining part plus gravitational field due to the removed part, let's call it E1 simply. So again, E1 vector is the gravitational field due to the removed part, okay, and this is, let's consider it just inside the shell, okay. We know that these two equal, sum of these two equals 0 because the gravitational field inside a thin spherical shell is 0, we know that. So this means that magnitude wise these two are equal, right? Now we can consider that just outside the gravitational field of the removed part will be minus E1. So we also have EP minus E1. This will be the gravitational field just outside because the gravitational field of the removed portion inside and outside the hole, just inside and just outside, will be in opposite directions. So that's why there's a minus sign here. And we know that the magnitude of this quantity is Gm by r square. Okay. So this means that 2 times EP, magnitude of EP is Gm by r square, and which simply means that the gravitational field due to one part, magnitude of gravitational field EP will be Gm by 2r square. That means C is correct and B is incorrect. Let's now look at gravitational potential at P. Well, one thing is for sure, we know that the gravitational potential just inside the shell and just outside the shell has same value, equal to minus Gm by r. We know that, okay, and which means that the contribution to gravitational potential by the small hole is negligible, can be put to 0. So that means that gravitational potential can be simply written as minus Gm by r. So if we look at the options, it is matching with option D. That means for question 8, C and D are the correct options. Let's go to the next question now. Question 9 says a 40 centimeter long string having a mass of 2.0 gram is fixed at both the ends. The tension in the string is 2 Newton. If the string is set into vibration using an oscillator of frequency 50 Hz, then string is vibrating in fundamental mode, string is vibrating in first overtone mode. Separation between consecutive notes is 40 centimeters, separation between consecutive notes is 20 centimeter. Okay, so obviously the question is based on the topic waves. In fact, it is standing waves in a string fixed at both ends. Now we know that the natural frequencies are given in such case as n by 2L into V. V is given as under root T by mu. Now let's put the values. N is integer. In fact, n can be 1, 2, 3, 4 and so on. So the value of L is 0.4 meter. 40 centimeters 0.4 meter. So this is 0.8 here. And this is tension is 2 Newton. Mass is 2 into 10 to the power minus 3 kg divided by again L, which is 0.4. Let's simplify it now. So this is n by 0.8 and the term inside the square root sign is 400, which is under root of which is 20. This is, let's simplify it still further. It is n into 200 divided by 8 or 25 n hertz. We can put it like this. So the fundamental frequency would have been 25 Hz, but it is being excited by an oscillator of frequency 50 Hz. That means it's vibrating in its first overtone mode or second harmonic mode. So that means option A is incorrect and option B is correct. Now, since it is oscillating in its first overtone mode, so that means there are two loops forming. The separation between consecutive notes is like this. And this is lambda by 2 and it's also equal to L by 2 because We can see that 2 times lambda by 2 is L here, and this is 20 centimeter because L is 40 centimeter. That means option D is correct and option C is incorrect. So that means for question 9, options B and D are correct. Let's go on to the next question now. Question 10 says, a stationary vertical cylindrical container of large height is filled with a gas of molar mass m at temperature T0. If the pressure at the bottom is 4 P0 and at the top is P0, then assume gravitational acceleration G is uniform. Height of cylinder is this much, height of cylinder is this much, pressure at middle of cylinder is this much, and pressure at middle of cylinder is this much. Okay. We shall apply the ideal gas equation and of course the variation of pressure in a fluid. Now we know that if the variation of pressure in the container, suppose this is the container which is filled with the gas, pressure is varying, so at some height h, and if we consider that this is dh, then we know that dp by dh is minus rho g. This we can apply, and rho is mass by volume. So the mass can be written as number of moles into molar mass, and of course the volume is here and this is G. We can apply the ideal gas equation to eliminate V because options do not involve V. So we can write, since PV is equal to nRT, so V can be substituted by nRT by P. So that means this is equal to minus n mg divided by nRT by P, and then we have a differential equation which can be solved. So dP by P then is equal to minus mg by RT dH. Temperature is constant. Let's integrate now. So at h equal to 0, the value of P has been given as 4 P0, and if the height is capital H, at the topmost point the pressure is given as P0. So this gives us that ln4 is equal to mgh by RT, and which means the height of cylinder is equal to RT ln4 divided by mg. If you look at the options, it is clearly matching with option A. Option A is correct and B is incorrect. Now to find pressure at middle of cylinder, we can use the value of which that we have got and integrate with different limits. We can perform integration, but we shall change the limits. We have to put upper limit as h by 2 and here pressure is P. So we shall get then ln P by 4 P0 is equal to then minus mg by RT, and we have to put h by 2 because the limit, because we have to find pressure at the middle of the container. So small h there is h by 2. So if we do that, it is equal to RT ln 4 divided by 2 mg, and let us simplify still further. This mg cancels, this RT cancels, and this gives us ln 4 P0 by P is equal to ln 4 by 2, and that means, this means that 4 P0 by P is actually equal to 2, and which gives us P is equal to 2 P0, and which means option D is also correct and option C is incorrect. Let's go on to the next question now.